in this series, Electronic Devices and Circuits, we will learn about the basic concepts of electronic science and also the working of the electronic component that drive our digital age. So, starting from the basic electronic component to the integrated circuit, we will going to explore that how these electronics component comes together to create the technology that shape our world. So in this series, we will be going through these contents. First, we will discuss about the signals and amplifiers. Next, we will move to the operational amplifier. Next, semiconductor physics, diodes, the BJT and the MOSFET. So welcome to the course and let's begin with the first lecture. When we hear about the word signal, what comes into our mind? A wave-like function, right? Yes, we represent a signal in the form of waves. So here we start with the basic definition of the signal. A signal is a quantity that contains information about the things of our physical world. Things like our voice and temperature, pressure, weather report, weather signal or some speed, etc. But these signals in these forms cannot be processed by the electronic circuits. So we need to convert them into some electrical form. And do you know which device we use for it? Yes, transducer. So a transducer is a device that converts these physical signal into some electrical forms. For example, of the transducers are temperature transducers, pressure transducer, resistance transducer, capacitance and inductance transducer. Okay, so there are two electrical forms of the signal that are voltage and current. The voltage source can be represented by its Thevenin equivalent and current source is represented by its Norton equivalent. So we represent voltage signal source by the circuit. Okay, so this is the circuit through which we represent a voltage source. And for the Norton equivalent, okay, so here we discuss a small concept about the value of the source resistance, which will help us to analyze the working of the amplifier. Okay, actually this resistance limits the ability of a voltage source to deliver its full strength to the load. So these there are some conditions for the signal source that should be maintained while analyzing any device or a network. So let's discuss these conditions. So we derive these conditions by using a voltage divider rule in the Thevenin equivalent circuit. So we connect a load here. So the voltage across RL will be if RS is 0, then the voltage VL will be equal to Vs. But this is not possible in the practical case. Ideal case, a voltage source can be represented by this value only. Okay, so this resistance Rs should be very less than RL. For the Norton equivalent, we find the current across this load resistor by using current division rule. So this is the value of current through the load. Okay, so if this load resistance, sorry, the source resistance is infinite, then we got the load current is equals to Is. Because if this resistance is very high, then all the current goes through this load resistance. So the condition, this Rs should be very greater than RL. Okay, so next we discuss the types of the signal. Okay, so the electrical forms of signal can be represented graphically by the two types of signal, analog signals and digital signals. So first is analog signal. So analog signal can be represented as like this, as it is analogous to our physical signal, so it is continuously varying with the time. And for the digital signal, it is represented as a sequence of number, where each sequence number represent signal's value at an instant of time. Okay, so these signals can be represented in the form of some predefined functions like sine wave or cosine wave. For this conversion, we use some mathematical functions, mathematical tools like Fourier series and Fourier transform. Fourier series actually allow us to represent any periodic signal of time as the sum of infinite number of sinusoids whose frequency are harmonically related. So these are also known as composite signals. And Fourier transform allow us to express any non-periodic signal of time into its frequency spectrum, which is a continuous function of frequency. So the voltage signal, if we represent it in a sine wave function, so we represent it's like that. Voltage signal can be represented as Va sine omega t, where omega is the angular frequency which is harmonically related to the other components of the signal, and this is the amplitude. This angular frequency can also be written as where f is the physical frequency. And digital signal can be represented by the binary signal of n number. If the number of bits of binary signal is n, so we represent a signal as up to okay, where b0 and bn-1 are the MSBs and NSBs of the signal. Okay, so that's all for this video. In the next video, we will discuss about the amplifiers and its types.